Dear learners of class 12th, today we are going to discuss chapter 13 Amines part 3 of chemistry. After this discussion, you will be able to describe the chemical reactions of amines, understand the various transformations involved in the chemistry of aryl amines, difference in electronegativity between nitrogen and hydrogen atoms, and the presence of unshared pair of electrons over the nitrogen atom makes amines reactive. The number of hydrogen atoms attached to the nitrogen atom also decides the course of reaction of amines. That is why primary, secondary and tertiary amines differ in many reactions. Moreover, amines behave as nucleophiles due to the presence of unshared electron pair. Let us understand the chemical reactions of amines in detail. Amines, being basic in nature, react with acids to form salts. Amine salts on treatment with a base like sodium hydroxide regenerate the parent amine. Amine salts are soluble in water but insoluble in organic solvents like ether. This reaction is the basis for the separation of amines from the non-basic organic compounds insoluble in water. The reaction of amines with mineral acids to form ammonium salts shows that these are basic in nature. Amines have an unshared pair of electrons on nitrogen atom, due to which they behave as Lewis base. Basic character of amines can be better understood in terms of their Kb and pKb values. Larger the value of Kb or smaller the value of pKb, stronger is the base. The pKb values of few amines are shown on the screen. pKb value of ammonia is 4.75. Aliphatic amines are stronger bases than ammonia due to the plus I effect, that is, the positive inductive effect of alkyl groups leading to high electron density on the nitrogen atom. Their pKb values lie in the range of 3 to 4.22. On the other hand, aromatic amines are weaker bases than ammonia due to the electron withdrawing nature of the aryl group. Besides inductive effect, there are other effects like solvation effect, steric hindrance, which affect the basic strength of amines. Basicity of amines is related to their structure. Basic character of an amine depends upon the ease of formation of the cation by accepting a proton from the acid. The more stable the cation is relative to the amine, more basic is the amine. Let us consider the reaction of an alkane amine and ammonia with a proton to compare their basicity. Due to the electron releasing nature of alkyl group, it pushes electrons towards nitrogen and thus makes the unshared electron pair more available for sharing with the proton of the acid. Moreover, the substituted ammonium ion formed from the amine gets stabilized due to the dispersal of the positive charge by the plus I effect of the alkyl group. Hence, alkyl amines are stronger bases than ammonia. The order of basicity of amines in the gaseous phase follows the expected order. That is, tertiary amine greater than secondary amine greater than primary amine greater than ammonia. The trend is not regular in the aqueous state as evident by their pKb values. In the aqueous phase, the substituted ammonium cations get stabilized. not only by electron releasing effect of the alkyl group but also by solvation with water molecules. The greater the size of the ion, lesser will be the solvation and the less stabilized is the ion. The order of stability of ions are as primary amine greater than secondary amine greater than tertiary amine, which is opposite to the inductive effect based order. Secondly, when the alkyl group is small like CH3 group, there is no steric hindrance to hydrogen bonding. In case the alkyl group is bigger than CH3 group, there will be steric hindrance to hydrogen bonding. Therefore, the change of nature of the alkyl group, that is from the methyl group to the ethyl group or CH3 group to C2H5 group, results in change of the order of basic strength. Thus, there is a subtle interplay of the inductive effect, solvation effect and steric hindrance of the alkyl group, which decides the basic strength of alkyl amines in the aqueous state. Let us compare the basicity of aryl amines and ammonia. pKb value of aniline is quite high. It is because in aniline or other aryl amines, the NH2 group is attached directly to the benzene ring. It results in the unshared electron pair on nitrogen atom to be in conjugation with the benzene ring and thus making it less available for the protonation. You may understand it through different resonating structures of aniline and will realize that aniline is a resonance hybrid of the 5 structures. On the other hand, anilium ion obtained by accepting a proton can have only 2 resonating structures called caculae. Greater the number of resonating structures, greater is the stability. Thus, you can infer that aniline with 5 resonating structures is more stable than anilium ion. Hence, the proton acceptability or the basic nature of aniline or other aromatic amines would be less than that of ammonia. In case of substituted aniline, it is observed that electron releasing groups like methoxy OCH3, methyl CH3 group increase basic strength, whereas electron withdrawing groups like nitro NO2, sulfonylic SO3H, carboxylic acid COOH, halide X decrease it. Amines undergo alkylation on reaction with alkyl halides. Aliphatic and aromatic primary and secondary amines react with acid chlorides, anhydrides and esters by nucleophilic substitution reaction. This reaction is known as acylation. The products obtained by acylation reaction are known as amides. The reaction is carried out in the presence of a base stronger than the amine, like pyridine, which removes HCl so formed and shifts the equilibrium to the right hand side. Amines also react with benzoyl chloride, that is C6H5COCl. This reaction is known as benzylation. Aliphatic and aromatic primary amines on heating with chloroform and ethanolic potassium hydroxide form isocyanides or carbylamines, which are foul smelling substances. Secondary and tertiary amines do not show this reaction. This reaction is known as carbylamine reaction or isocyanide test and is used as a test for primary amines. 3 classes of amines react differently with nitrous acid, which is prepared in situ from a mineral acid and sodium nitrite. Primary aliphatic amines react with nitrous acid to form aliphatic diazonium salts, which being unstable liberate nitrogen gas quantitatively, and alcohols. Quantitative evolution of nitrogen is used in estimation of amino acids and proteins. Aromatic amines react with nitrous acid at low temperatures of 273 to 278 Kelvin to form diazonium salts, a very important class of compounds used for synthesis of a variety of aromatic compounds. Secondary and tertiary amines react with nitrous acid in a different manner. Benzene sulfonyl chloride C6H5SO2Cl, which is also known as Hinsberg's reagent, react with primary and secondary amines to form sulfonamides. The reaction of benzene sulfonyl chloride with primary amine yields N-ethyl benzene sulfonyl amide. In the reaction with secondary amine, N,N-diethyl benzene sulfonamide is formed. Tertiary amines do not react with benzene sulfonyl chloride. Aniline reacts with bromine water at room temperature to give a white precipitate of 2,4,6-tribromoaniline. Direct nitration of aniline yields terry-oxidation products in addition to the nitro derivatives. That is why, besides the ortho and para derivatives, significant amount of meta derivative is also formed. However, by protecting the NH2 group by acetylation reaction with acetic anhydride, the nitration reaction can be controlled, and the para-nitro derivative can be obtained as the major product. Aniline reacts with concentrated sulfuric acid to form anilinium hydrogen sulfate, which on heating with sulfuric acid at 453 to 473 Kelvin produces para-aminobenzene sulfonic acid, commonly known as sulfonilic acid, as the major product. Aniline does not undergo Friedel-Crafts reaction, alkylation as well as acetylation due to salt formation with aluminium chloride, the Lewis acid which is used as a catalyst. To summarize the discussion, let us have a recapitulation of the major reactions. Aniline is a weaker base than ethylamine. Primary and secondary amines form acyl derivatives with acid anhydrides as well as acid chlorides. Carbylamine test is given by only primary amines. Amino group in aniline is ortho and para-directing and is highly activating in nature. Nitration of aniline with nitrating mixture gives meta-nitroaniline as the major product. Sulfonation of aniline with concentrated sulfuric acid gives sulfonilic acid which exists as a Zwitter ion. Hinsberg's reagent is benzene sulfonyl chloride, which can be used to distinguish primary, secondary and tertiary amines. Before we end this discussion, let me leave you with an assignment. You are expected to arrange the compounds as shown on the screen in increasing order of the basic strength. I hope you understood all the concepts discussed in this discussion. Hoping to meet you again. Till then, take care.